20 minus 40 over 3, and that is 20 over 3. Okay, so your answer as an XY pair is 20 over 3, comma 40 over 3. And checking using the graphing calculator. Remember that in order to use a graphing calculator, we got to really have equations as y equals. So this equation is really y equals 20 minus x. The top equation from here, okay, if I eliminate, if I isolate the y variable, I get y is equal to 80 minus 2x over 5. These are the two equations that I need to put into my graphing calculator, okay? So let's go do that. Clear that, clear that. The top one is 20 minus x, and the bottom one is parenthesis 80 minus 2x, all divided by 5, and graph that. Ooh. Looks like I need to change my windows, obviously. So I'm going to make 40 over 3. I'm going to make my windows, let's say, okay, the x is okay. Let's just change the y values. Let's just go negative 20 to 20. I could do zoom fit as well, and that would have worked as well. So there are your two lines there, and here's the intersection point right there. Okay, and we can do the same thing. We can go second calc, intersect number 5, move the cursor closer to where the intersection is, and that's good enough there. Enter, enter again, enter, and here come your answers. So obviously your answers are going to be decimals. So the answers are x is 6.66, and what was y? Y was 13.33. Okay, which is what we have here. Okay, same thing. Okay, except I've got again, I want to reiterate the word exact. I've been using that since September, and people still don't understand what is exact and what is not exact. These are not exact because they are decimal answers, okay? They're decimal answers. These are exact. So exact answers are either fractions, okay, or rational numbers, radicals, okay, like square root of 2, the symbol E standing for 2.718 whatever, the symbol pi, or it could even be an expression, like for example x equals ln 2 is an exact answer to some equation, as opposed to x equals 0.6931, okay? That's not exact. All right, so again, gone on record now as having explained to you what exact means, okay? All right, so we've done substitution, we've done elimination, and the next one's going to be graphing, I take it. And I assume we're going to be graphing by hand. Oh, it says solve graphically and check algebraically, so I assume we are graphing by hand, okay, not using the TI-84. All right, so we got to really fix the bottom equation. The bottom equation looks like it's a circle. So we need to fix that. And how do we fix that? Oh, let me go kind of snip this. Okay. This is going to be a circle, so I need to complete the square. And I'm going to do x squared minus 4x. And I'm going to add a 4 to this to complete the x part as a square. Plus y squared, and I need to add a 4 on the other side, which gives me that x minus 2 squared plus y squared equals 4. So this is a circle, center 2, 0, radius 2. So I need to graph that, okay? And it's going to be kind of winging it here. So notice when I graph, I have my x-axis and y-axis labeled. I have my scale. And then I just graph that. So my center is at 2, 0. Center 2, 0, radius equals 2. So my center is out here. Let me change colors on this. My center is out here. And my radius is 2, so it should go through that point. It goes through that point. goes through about that point and goes about through that point. So I'm going to wing this thing. Not a great freehand circle drawer, but ugly. I'm sorry, kind of ugly. Well, I don't have graph paper there. If I had, maybe it would have been a little easier. And then I need to graph this line. Okay, so this line is y equals 4 minus x. It's got a slope of -1. The y-intercept is 4, so it's going to be going through 2, 3. It's going to be going through there, and its slope is 1. So it looks like it's going to be something like this. Wow, pretty ugly stuff. Don't like that at all. So should have really done a better job. Let me change that again. I'm going to try and do a better one now. So when x is 0, y is 4. When x is 1, y is 3. So it's going through there. Let me try and get a straight edge out here, put it on my computer, and see if I can do a better job there. That's a little better. So my intersections are here and here. So this one looks like x equals 1. Does that look right? X equals 1 and y equals 2. It doesn't fit the first equation. So what's it going to be? Is the other one clear as well? Looks like... Oh, I know what the problem is. My circle's not done right. Here's my center, but this should have been 2 units, and it's not. The circle should have come out this way here. Let me erase this and kind of do it over again, see if I can do a better job of that. You can see I'm kind of anal about these things. That's why you really need to do this on graph paper. I need to erase. No, I want to erase that. So radius is 2, so here's 1. Here's 2. So your circle should really be like this. Which means now that my line needs to be extended. I'm going to do that. Extend my line. I'm going to use a straight edge here. And somewhere out here. God, it's going to be hard to estimate what these points are. To me, this one looks like x equals 1 and y equals 2, but that doesn't fit the equations that we have. This one looks like, this is 1, 2, 3. This one looks like 3.5, comma 2. So 3.5, comma -2, I'd say. I'm just going to wing this and see whether that really works, because I'm ultimately going to go check it algebraically, and then I'll fix these points. Okay. So to do it algebraically, what I'm going to do is I'm going to use the substitution method. And from here, I get y equals 4 minus x. I'm going to take that and shove it in.